This video is about meters and meter usage. Now, the reason we spend so much time on meters and how to use a meter is because it is probably the most often used tool as an HVAC technician. Should be the first tool out of your tool bag and the last tool you put away. You want to, before you use your meter, make sure you read the manual that came with it and understand all of its functions. There's two types of meters on the market. You have analog meters and you have digital meters. The analog meters have been the workhorse for years. They were the first meters on the market. They are extremely sensitive and do not stand up well to being tossed around trucks. They're still used today when technicians are looking for extremely accurate measurements. Digital meters have almost completely replaced the analog ones in the industry. Digital meters stand up to much better to being dropped, tossed around a truck, and a wide range of temperatures. Digital meters are accurate and usually auto range. There are several basic electrical rules you must understand prior to understanding what a meter is telling you. Most of these rules are based on voltage and resistance. Series is the first one of the terms you'll hear about. You'll hear technicians talk about something being in series with something else. That series means in the same line as. There's only one path for electricity to flow. Parallel means next to. When you hear technicians speak about things being in parallel, it just means they're next to each other. They're all receiving source voltage. So the light bulb is in parallel with the fan motor, which is in parallel with the compressor, and is parallel with the heater. That's all it means, next to. Receives full source voltage. Open circuits are circuits that do not have a complete path for electricity to flow. Circuits require a source, a switch, a path, and a load. If any of these components has a break or open in it, the current cannot complete its circuit. In this case, the switch is open. It's an open circuit. When you measure voltage across an open circuit, you will always get a reading of source voltage. When you measure resistance across an open circuit, you'll always get a reading infinity, or most of your meters will display OL. A closed or complete circuit is one that has a complete path, source, switch, and load. The load is operational in a complete circuit. The switch is closed in a complete circuit. When measuring voltage across a switch in a complete circuit, you will always get 0 volts. When measuring voltage across a complete circuit, you'll always get source. Voltage across a load is identical if the load is working or if the load is bad. If you have all the switches closed and measure voltage across the load, the circuit is good. If the load is not working, then you have a bad load. If the load is working, then the voltage you read is the voltage that load is using. The current or amperage you measure will be 0 in an open circuit. Again, no path for electricity to flow. Current will be 0 in an open circuit. In a closed circuit, the amperage you measure may change based on where you take your readings. Meters will measure voltage, current, resistance, capacitance, frequency, and temperature. Voltage is the most frequent measurement you make. To measure voltage, turn your meter on, set it to volts, or V, depending on what your meter shows. Make sure your leads are plugged into the correct place on the meter. Put the leads in parallel with, which means next to, the point in the circuit you're trying to measure. Hold the lead steady without touching any of the metal to your fingers or each other. Watch the display until the meter stabilizes on a number. That is your reading. So if you want to measure the voltage across switch 1, you're going to put your meter leads on either side of switch 1 so your meter's in parallel with that switch. Voltage across an open switch is always source. Okay? Again, voltage across an open switch is always source. Voltage across a closed switch now turns to 0. Again, the rule to remember, voltage across an open switch is source, which means open across a closed switch is 0, because it's either open or closed. There's no in between. Voltage across a non-powered load is always 0. Notice the leads are on each side of the load, but the switch is open, so it's a non-powered load. Voltage across a powered load is always source. Voltage across an open powered load is always source because that broken winding in this case it's a light bulb, the broken filament acts as an open switch. So wait a sec, how do you know if the source is working or not? Use your eyes. Use other means of measuring if the source is working. The difference from here to here is actually pretty easy. Okay? This will have 0 amperage. This will have amperage. So again, look at the amperage, whether or not you want to tell if the switch is, if it's working or not working. Voltage across a full circuit is always source. Now, to measure resistance, you want to disconnect the circuit from the source. With resistance measurements, there cannot be any power on the circuit. Decide what component or portion of the circuit you would like to measure, disconnect the wires to, and remove that part. Set your meter to ohms and touch one lead directly to another. This will show a reading of 0 on your meter. Okay, we always want to check our leads first. If it does not, check your lead for damage and make sure they're plugged into the right spots on your meter. Now, touch one lead to each side of the component or isolated portion of the circuit that you're testing. Wait for the display to stabilize and record that number. This is the resistance. Resistance is shown in ohms. So again, we make sure that the system is disconnected and we take a resistance across the switch. Resistance across an open switch is always infinite, or OL. Resistance across a closed switch is always 0. You have two choices: infinite, which is OL, or 0. Open switch is infinite, closed switch is 0. Resistance across a good load is some number. It's going to vary depending on the load. Resistance across an open load is OL, or infinity. To measure current, the first step is to determine which method you would want to use. It's possible to use the clamp on for higher voltages and currents. It's possible to put the meter in line for lower voltages and currents. Make sure you close the switch to energize the circuit. So to measure the current with the clamp on meter, make sure the system is running. Clamp the meter around a single wire and wait till the numbers stabilize. This is your amperage reading. Now, if you use lower amps, lower currents, you might want to wrap the meter around, you might want to wrap the wire around the meter 10 times. If you wrap the wire around the meter 10 times and your reading is 2 amps, divide that number by the number of times you have the wire wrapped around the clamp. If the current is too low, consider putting the meter in line. If that's not possible, wrap the wire around the clamp 5 to 10 times, take your reading, divide the number you get by the number of times the wire is wrapped around the clamp. Unfortunately, most of the time you'll not just have one switch controlling a load. This is where we start to use the hop-scotch method of checking a circuit. Most circuits in the HVAC industry will have more than one control device. You have to have a reliable, organized method to find problems in a circuit. This is why most good technicians start off diagnostics by using the hop-scotch method to trace circuits. The procedure for this is very simple. First, make sure your meter is set on volts and make sure the leads are correctly plugged into the appropriate place on the meter. Next, check voltage across the two endpoints of the circuit, line and neutral or line and line. Then put one lead on the start point. In our case, we're going to use L1. Keep that lead there. Most people will use an alligator clip to put it right where it needs to be. Use the second lead to go from point to point in the circuit before and after each switching device in load, checking for opens until you find the problem. This is just one of the examples, okay? Voltage across L1 and neutral is 120. We have power to the circuit. That's important. Don't go further if you don't have power to the circuit. Now, we leave one lead on L, and we go to the line side of switch 1. We have 0. So the wire from L to switch 1 is good. Then we go voltage across L1 in the load side of switch 1. It's 120. This means that switch 1 is open. Remember, voltage across an open switch is always source. Now, in a schematics, it's easy to see if the switch is open or closed. But in real life, this switch is inside some enclosure, so you have to be able to tell using your meter what's open and closed. You can verify this is the problem by starting from neutral. Okay, we go from neutral to the neutral side of B1, 0, fine. Go to neutral to the line side of B1, 0, fine. Go from neutral to the line side of switch 1, 120 volts. Again, you have verified the problem. Switch 1 is open. So you use your meter. You're going to use voltage most often. Things to remember, very important things, is if you're using your meter in resistance to check the ohm readings, you cannot have any power on the circuit whatsoever.